Okay, here's our last day in preparation for your final. So we're going to look at chapter 6 and 7, matrices, as well as sequences and series. Okay, so let's look at this first one. You can probably do it on your own. It says compute the given expression, where I sub 2 is the 2 by 2 identity. So notice they don't make you recognize what that I sub 2 is, but you should know what the 2 by 2 identity is. So in this case, if I take negative 2a, I'm going to go ahead and have negative 4, positive 2, negative 14, 18. And if I add 4 times matrix B, I get 20, negative 12, 16, 28. And then 2 times the identity. Remember, the identity is just 1, 0, 0, 1, so 2, 0, 0, 2. Think about adding the numbers in the same spot. So negative 4 plus 20 plus 2 would give me 18. As I keep going, I've got 2 plus negative 12 plus 0 is a negative 10. And then I got negative 14 plus 16 is 2 plus 0 is 2. And last but not least, I've got 18 plus 28 plus 2. I must have missed a negative sign there. Sure enough, I did. That was negative 18. Makes a little bit more sense. Negative 18 plus 2, so we get 10, 12 there at the end. So we got our 2 by 2 matrix. And notice you don't have to go all the way through. If you get far enough and you feel confident, like notice just from that first and second term, you know A has to be the answer. I'd go ahead and like move on just because, hey, there may be some problems that take you longer, right? And it's all multiple choice. Okay, the inverse, how to use inverses to solve a matrix. Solve system of matrices. You take the inverse of the coefficients and multiply times the answers. Okay, so let's go ahead and find the inverse of this matrix. So if I find the inverse, sometimes I note it with a little negative 1. We're going to do 1 over the determinant. So 3 times negative 1 minus 5 times the negative 4. We flip-flop the negative 1 and the 3, and we change the signs of the 4 and the 5. So this is 1 over negative 3 plus 20. This is going to stay the same. So this is 1/17, negative 1, 4, negative 5, 3. You can either leave it like that, or if they're writing it as a single matrix, then we'd have something like negative 1/17, 4/17, negative 5/17, or 3/17. So you're just going to have to pay attention to kind of what the multiple choice is asking you for. But either of these answers are correct. Okay, if I ask you to multiply a matrix, remember you're doing row times a column. If it helps you, think about this as a 3 by 3 times a 3 by 1. So when I multiply these together, 3 and 3 match up in the middle. We should result in a 3 by 3. So we should have one column with 3 rows. Maybe I'll make that just a little bigger, so we got plenty of space to write. Okay, so think about, and if you need to kind of rearrange it, you can, row times column. So this is negative 2x plus y plus 2z. And then for the second one, we're now in the second row. We're still multiplied times this first column. So 3x plus 2y plus 4z. Last but not least here, row times column. 0x minus 2y plus 4z. You wouldn't have to write in that 0x, but you sure can. So now when it says solve the system of linear equations using matrix algebra, Matrix algebra must be used to receive credit. Note the inverse is given to you. Once again, like, hey, can you check it other ways? Yeah, by all means, but the inverse is definitely going to be the easiest here. But we're not checking your work. So notice this first matrix is the coefficients of the variables. That little -1 means the inverse. So they're giving you the inverse. So what we're going to do is we're going to take that inverse, and it's good to recognize which one it is, right? So that's the matrix on the right, and we are going to multiply it times the answers of our system. And I think it helps some of you to have it up here. So we're going to multiply it times 12, 8 times -4. So the idea here is to multiply inverse by the answers, which is actually the matrix on the right, though. So just be a little careful there. So here we should have 3 rows and 1 column again. Okay, row times column. So here we have negative, I missed a negative, that 12, close call. We've got -84 plus 24 plus 16. The way I got that is 7 times -12 is -84, 3 times 8 is 24, -4 times 4 is 16. Now if I go to the next one, I've got -3, the second row, times the first column, so -3 times -12 is 36, -3 times 8 is -24, 4 times -4 is -16. Last but not least, 4 times -12 is -48, 4 times 8 is 32, -4 times -4 is positive 16. Just remember, it's 1/4 times all these. So we get 1/4 times, if I add that top row together, I get -44. And then I have that second row, and I do 36 minus 24 minus 16, I get -4. The bottom row, I end up with 0. As I distribute that 1/4 to each of them, I get -11, -1, 0. So x is -11, y is -1, z is 0. Okay. So what's the idea behind Cramer's rule? Cramer's rule, the idea behind that is like to find x, let's say we're going to do 2 determinants. We're going to do d of x over d of y. Just d. Where d is the determinant of the coefficient matrix and d of x is the determinant of the coefficient matrix as well, where the x column, so in this case that's the first column, is replaced with answers. All right. Okay, I am actually going to change this example because I think a 2 by 2, you're really good at it, but I think we need to practice actually finding the 3 by 3. So let's go ahead and I'm going to give you the following system. So we have 2x plus y plus 3z equals negative 2. Negative x plus 2y minus 3z equals 1. And x minus 2y plus 4z equals 3. And let's just say solve for y. Okay. So let's first find just our regular determinant. So a 3 by 3. So 2, 1, 3, negative 1, 2, negative 3, 1, negative 2, 4. I think most of you like the diagonal method, so I'm just going to repeat those first two columns. Okay. So we multiply down. So 2 times 2 times 4 is 16. Plus 1 times negative 3 times 1 is negative 3. 3 times negative 1 times negative 2 is positive 6. We're going to subtract the x's. So minus 6. Negative 2 times negative 3 is 6 times 2 is 12. And then we've got minus a negative 4. So the determinant here, we add 16 plus negative 3 plus 6 minus 6 minus 12 plus 4, we end up with a determinant of 5. Okay, now let's think about the same thing, but we're going to replace the x column. So that first column we're going to replace with a negative 2, negative 1, and 3. The second two columns do not change at all. I'm going to use the diagonal method again and rewrite those first two. Okay, multiply down and add. So we get negative 16 plus a negative 9 plus 6. We're going to subtract the x's. So 3 times 2 is 6 times another one is 18. And then we have, let me just move that over just a smidge. Sorry about that. That's not going to work. That's okay. I'll keep writing there. Minus, we have a 4 and then a 3, so that's a negative 12. Minus negative 4. Okay, so negative 16 minus 9 plus 6 minus 18 plus 12 plus 4. We get negative, oh my goodness, we're solving for y, not x. I'm going to have to go back. Sorry, guys. So let's go back to square one. This is why you read the directions really carefully so you don't mess up like something like that. Okay, so let's look at this again. If you're solving for y, remember we want d sub y. So our first column will stay the same, but our second column will now become the answers. Okay, let's try that again. So now we're going to multiply up and multiply down. So we get positive 8 plus 6 plus a negative 9 and subtract the downs. So minus a negative 3 minus 18 and minus 8. So 9 plus 6, 8 plus 6 minus 9 plus 3 minus 18 minus 8. Oh, that 18 though is a, oh, that should be a positive 2. How did I mess it up? Positive 2 at the beginning there. Okay, so what else does that change? A negative 8 at the beginning. Oh my goodness, I messed up again. Okay, oh my goodness. This is equal to 1. Sorry, can you tell I'm looking at an answer key? Okay, so let's go check these signs. So we have positive 8, and then we have a positive 6, and negative 9. As we multiply up, we have a positive 3, a negative 18, and a positive 8. Okay, I gotta change that to be a negative 18. Oh man. Okay, so it'd be minus 3 minus a negative 18 minus 8. This one at the beginning is a positive. So 8 plus 16 minus 9 minus 3 plus 18 minus 8. Okay, there we go. Now we're on track. So we end up getting 12. So now we've got 12. So y would equal d sub y over d, which equals 12 over 5. So that would be your answer. Okay. Now let's go ahead and do some partial fraction decomposition. Okay. How fun, right? So recall that as you break up the denominator and numerator, we're going to break up, in this case, for partial fraction decomposition, you break up the denominator at the bottom and write it down as far as linear and quadratic factors. If it's a linear, you put a constant on top, such as a. If it's a quadratic, you put a linear on top, such as ax plus b. If it's repeated, then you still, for something like x plus 1 squared, right, you're going to break it down into x plus 1, but it's still a constant. You have x plus 1 squared. Whereas if it's same as, so if it's repeated, you follow the same rules. Follow rules of linear / quadratic. So this is an example. So careful, repeated linear is still going to follow the rules of linear. Okay, so if we want to go ahead and do this one, first we need to start by factoring the denominator. Okay, I can still factor x squared minus 6x minus 9, and that factors to x minus 3 squared. Okay, so if I'm going to go ahead and solve this, I'm going to break it down into a over x plus b over x minus 3 plus c over x minus 3 squared. Okay, so multiply both sides by the x times x minus 3 squared, and then think about multiplying each of these by that as well. Okay, so we get 45 minus 9x equals a times x minus 3 squared plus bx times x minus 3 plus cx. Okay, I kind of know what x minus 3 squared is, but if you want to go ahead and multiply it out, we should get ax squared. We'll get minus 6x, so minus 6ax, plus 9, so plus 9a. Plus bx squared minus 3bx plus cx. So let's take a look. We've got our x squareds. A plus b, but there's nothing on the left, so we'll say it's 0. We got our x's. So we've got negative 6a minus 3b plus c equals negative 9. And then we've got that 9a equals 45. So a is a great place to start. A equals 5. If a equals 5, a plus b equals 0, b has to be a negative 5. Last but not least, let's plug it in at the bottom. So 6 times 5 minus 3 times a negative 5 plus c equals a negative 9. Negative 30 plus 15 plus c equals negative 9. Negative 15 plus c equals negative 9. C equals 6. So if I want to rewrite it then, I'd have 5 over x plus a negative 5 over x minus 3 plus 6 over x minus 3 squared. Okay, that's it for matrices. As far as like reduced row echelon form, remember it just takes so long. They're likely not to have something like that. And especially where they can't have you check your work. I've seen questions where it's like, hey, find this 2 by 2 inverse by using that. But they can't have you check your work here to do something like that. So now let's go ahead. Remember, the difference between arithmetic is you add / subtract. And geometric, you can think about your multiplying or dividing to get the sequence. Okay. So find the 7th term of a geometric sequence with a first term of 2 and a common ratio of 1. Okay. For the record, remember you can look at your formula sheet, but we'd have a sub 1. If we look at our formula sheet, you have a sub 1. It says r to the n minus 1. So if we're finding the 7th term, our first term is 2, our common ratio is negative 3, and then we're doing 7 minus 1, which you could call the 6, but at this stage, you know, it's just making sure you type things in correctly, and we get a 1,458. Okay, for series, which formulas do you use? So, remember for series, you're going to use the S sub n. So for an arithmetic one, you've got this, and you can look at your formula sheet, but it's the n divided by 2, a sub 1, a sub n. For geometric, we have two formulas. We have the a sub 1, 1 minus r to the n over 1 minus r. We also have this s sub infinity, a sub 1 minus r. So remember the difference between these is if it's finite or infinite. This one's for if it's finite. This is for it's infinite. Remember that the absolute value of r also has to be less than 1 here. If it's not less than 1, we're going to run into some issues, and you will not be able to use that as well. So just make sure that you check that condition kind of before you go on, such that you're not assuming something that's not true. Or you're plugging something in, just kind of blindly assuming. Okay, so let's take a look. Determine whether this infinite geometric series converges or diverges. So first we have to decide what's happening here. We're timesing by 1/2. And a ratio is timesing. I mean, you could say it's dividing by 2, but that's the same as multiplying by 1/2. So then my s sub infinity is going to equal 12 divided by 1 minus 1/2. So we have 12 over 1/2. So the fact that r is less than 1, we know that it's going to converge. And then we just have 12 times 2, so we get 24. So B is the correct answer. Okay, what's the sum of this series? Okay, so this one, once again, is a geometric, right? We're timesing, but it is for a finite. So we're going to use s sub 8. So our first term, though, if I plug 1 in there, I get 2 times 3/2 to the 1 minus 1, which is to the 0. So I just get 2 times 1 minus 3/2 to the 8th, all over 1 minus 3/2. You can type that all in your calculator if you're careful. If you're not so careful, then we get 2 times 1 minus, I'm just going to type it all in. So make sure you use enough parentheses. My one recommendation, especially around that denominator, or I know your calculator will kind of let you do a fraction for you if you want. So here I get 6305 all over 64. Okay, one last one. A brick staircase has a total of 11 steps. The bottom requires 103 bricks. Each consecutive step requires 5 less bricks than the prior one. Okay, so this one we know that we're going to sum of 11 together, right? So we're going to have 11 divided by 2. Our first step, the bottom step, has 103 bricks. Plus the problem is I don't know what the 11th term is. So this is where we're going to have to do a little side work. We're going to do a sub 11 equals my first term, which is 103, plus it says n minus 1, so 11 minus 1 times the difference, which in this case is a negative 5. So in this case we get 53 as the 11th step. There's 53 bricks in the 11th one. So we get 103 plus 53. Type that in your calculator, and we get 858 bricks. Okay, remember chapter 7 is a little bit more emphasized because we haven't been tested on that, so make sure you know this stuff the best. Well, not the